Hi, and welcome to Chapter 1 for Math 1120 Calculus. Today we're going to start with this Introduction to Functions, Chapter 1. Up at the top, just so you have your notes, it says that you have studied functions, you've looked at their equations and the graphs in college algebra. Because these topics play an important part in the development of calculus, they are reviewed in detail in this chapter. But only a few of these sections will be covered in class. The rest, if you need to, should be reviewed on your own. Okay? So please make sure you look at all of the stuff in Chapter 1, and if you need any help, you would just reach out and let me know. All right, so section 1.1 is Introduction to Functions. In this section, we're going to review the definition of functions, which is a special relationship between two variables. And in part A of this section, we're going to review some basic definitions and determine if a relationship between two variables actually represents a function. And then in part B, we'll look at reviewing operations with functions. All right, so then we just have our overview of what we're going to cover. So today in section 1.1, we're going to look at evaluating a function. We're going to go back and look at the vertical line test and see how that helps us determine whether or not a graph is a function or not. And then we're going to look at finding the domain of a function, which is very important in this course. Okay? All right, so a couple of concepts and definitions that we're going to need along the way. Number one is the word relation. Okay, that definition, a relation is just a collection of ordered pairs. It can be anything. It doesn't have to be numbers. Okay, typically in math, they're going to be numbers. But it can be really a collection of any kinds of ordered pairs. Okay, anything. All right, the second definition, okay, is about a function. So it says, let the domain D and the range R be two sets of real numbers. Then a function f is a rule that matches each number x in the domain with exactly one number y, sometimes also referred to as f of x, in the range. So what that says is that the x values cannot repeat in the relation. So the easiest way to kind of remember if something is a function when you're looking at numbers is you want to make sure that all the x values are different. Okay, that's what this says kind of in a nutshell, but that's always kind of what we look for, the easy way, if we're given a set of numbers. All right, now domain and range. D is called the domain of a function or the collection of input values, and then R is called the range of f or the collection of output values. So you always need something to go in to figure out what's coming out, basically. If you're working any kind of equation, you put something in the equation and then you get something out of it. So that's what we call the domain, the input values, and then the range, the output values. All right, number 4 says x is the independent variable of a function and y is the dependent variable of the function. That's important when we start looking at this, but always when we're looking at equations in algebra, when x and y are involved, x is always independent and y is dependent. Sometimes you're going to get functions that don't have x and y's. They might use an m and n, or they might use a's and b's. So it gets a little confusing, but typically when we're talking about functions and we're working with functions, the equations given to you will always be in terms of x and y. Okay? All right, and then the last thing is called the vertical line test. And that states that if any vertical line intersects a graph at more than one point, then the graph does not represent a function. So in numbers 2, 3, and 4, we were talking about kind of equations and looking at x's and y's. In number 5, if you're given a graph, then to tell if that's a function, you would look at or use what's called the vertical line test. So you don't have to have an equation. You can just look at the graph and know if you have a function or not. And remember that a function, all the x's had to be different, right? That's what a function was. So the vertical line test kind of helps with that. We'll look at that when we go through some of those graphs. All right, so let's look at some practice problems and make sure we're okay with function notation and functions in general. So again, these are all reviewing what you should already know, and hopefully once you see it, it'll be good reminders of how to do these things. And if you need any more help, please let me know. Okay? All right, so number 1, function notation. So you're given a function. You read this f of x. Remember, that's function notation. That does not say f times x. That's f of x equals 3x squared minus x plus 2. And always remember that f of x is the same thing as y. Remember up here, okay, it said that it had to match with exactly one number, y or f of x. These can be interchanged, okay? Always remember that. That's really important. So when I look at this function right here, I can also think of it as y equals 3x squared minus x plus 2. Okay, those are exactly the same thing. All right, so it just depends on when you need what, but you can interchange those. All right, so we're finding f of negative 3. So remember that whatever is in the parentheses is going to be in place of x. Okay, so whatever they ask you to put in place of x, you're going to replace this number, or whatever's in there, with all the x's on the right side. So if you're finding f of negative 3, then that means that all the x's on this side would change to negative 3. And when you use negative numbers, please put them in parentheses, okay? Especially if you're using your calculator. Sometimes if you don't, you're going to get it wrong. So notice I had 3x squared, so now I have 3 times negative 3 squared, minus x, so now I have minus negative 3, plus 2. So everywhere there was an x in the function, I'm now replacing it with whatever they gave me. And in this case, it was negative 3. You can use your calculator for this, or you can just do it in your head, however you'd like to do it. I'm just going to work it out, okay? So I do powers first. So negative 3 squared means negative 3 times negative 3, which is a positive 9. And then when you subtract a negative number, that changes that to plus 3. Okay. Then I'm going to do my multiplication first. So 3 times 9 is 27. 27 plus 3 plus 2. So 27 plus 3 is 30. Plus 2 is 32. Okay, so that would be my answer for f of negative 3. So f of negative 3 equals 32. Now remember, this was the input value. This is the output. So this was x, which means this is y. Okay, so that was your x value. Your output is y. All right, next one is f of 2. So f of 2 means I'm going to replace this side, any x over here, I'm going to replace with 2. So 3 times 2 squared minus 2 plus 2. Okay, now I didn't put this in parentheses because, again, it was a positive number. I put this in parentheses because I needed to square it first. And you guys got to remember that you square before you multiply. So do not make that 6 and then square. Okay, you got to do order of operations. All right, so leave the 3 there. Go ahead and square the 2. So 2 squared is 4. And then I'll leave the rest. Okay. All right, now I'm going to multiply. 3 times 4 is 12. And then 12 minus 2 plus 2. So 12 minus 2 is 10. 10 plus 2 is 12. So again, 2 is the input, that's x. 12 is the output, that is y. Okay? All right, f of t. What does that mean to do? Some of you guys get confused when there's more than just a number or something else in there. But same rule applies. Whatever is in this parentheses replaces the x's on the right. So I'm going to replace these x's with t's. That's all it says to do. So that's going to be 3t squared minus t plus 2. Okay, and I can't do anything else. I can't add that because those are variables. So that is your answer. All it asked to do was put t in place of x. So sometimes you can't work them out anymore. Sometimes you can. Just depends. All right. Part D says f of 2t. Again, when you have more than one thing in there, put it in parentheses when you're putting it into the function. So what this says is everywhere there's an x on this side, you're going to replace those x's with 2t. Okay? So 3 times, so instead of this x, you're going to put 2t, and you're going to square it, minus x, so in place of that x, you're going to put 2t, and then plus 2. Okay, so 3, there's the x, and squared, minus, there's another x, plus 2. So my x is just changed to 2t. Okay. All right, so again, remember, we're going to do powers first, leave everything else the way it is for a minute. So 3 times 2t squared. 2t squared means 2t times 2t, right? When you square something, you multiply it by itself. So 2t times 2t would be 4t squared. So that's 4t squared minus 2t plus 2. All right, and now I can multiply. So 3 times 4t squared is 12t squared minus 2t plus 2. All right, and when you're adding variables, you have to have the same like variables in order to add. So there's nothing I can add here. The only thing I can add to t squares are more t squares. So I don't have any more t squares. The only thing I can add to t's are more t's, which I don't have, and then that's just the number. So that is your answer. Okay, nothing else I could do with that. All right, and then part E says f of t squared. All right, so again, whatever is in here will replace just the x. So I got to put a t squared here and a t squared there. Okay, so f of t squared says on this side, put a t squared where the x's are. So 3t squared squared minus t squared plus 2. Okay, so I replace the x's with t squares. All right, again, don't forget to do your powers first. So t squared squared, remember that means t squared times t squared. All right, when you square something. So t squared times t squared is t to the 4th minus t squared plus 2. Okay. And then multiply 3 times t to the 4th. That's 3t to the 4th minus t squared plus 2. And again, nothing here can be added because they're different variable, different exponents. So that is your answer. Okay. All right. So functions. Okay. All right. Let's look at number 2. Here's another function. F of x equals 1 minus 2x squared. So we're going to go through and do the exact same thing. We're going to find these function values. So whatever's in the parentheses, we're going to replace that with the x's on the right side. And in this problem, there is only one x over here, so I only have to replace it in that one spot. All right, so f of 9, start off kind of basic. So wherever there's an x, you're going to replace the x's with the number 9. So 1 minus 2 times 9 squared. Okay. Remember, do your powers first. So leave the 1 and the minus 2, and then go ahead and do 9 squared, which is 81. 9 times 9 is 81. Okay. All right. Then you do multiplication, right? So if you're doing multiplication, then you're going to do 2 times 81. So 1 minus 2 times 81, that would be 162. And then you can subtract 1 minus 162, that would equal a negative 161. Okay? So remember, input, that's x, output, that's y. All right, f of 3a. So remember what that means. We're going to replace any x in the problem on the right with 3a. Okay? So we've got 1 minus 2 times 3a squared. So I replace that x with 3a. Again, if it's a bigger than one number or even not, I would still put it in parentheses because you're getting ready to square it. All right, so we're going to leave that 1 minus 2 again because the first thing we have to do is square 3a. So 3a squared means 3a times 3a. Okay? So if you multiply that, that's 9a squared. So 9a squared. Okay. Now you're going to multiply. So 1 minus 2 times 9a squared would be 18a squared. And then I'm done because the only thing I can add or subtract to an a squared term is another a squared term, and I don't have that, I just have 1. So sometimes your answer is a expression with variables in it. Just kind of depends on what you have and what you can do with it. All right, part C, f of x plus 4. All right, so again, don't let this throw you. Whatever is in the parentheses replaces the x in the problem. So instead of this x right here, we're going to replace it with whatever's here, which is x plus 4. So f of x plus 4 equals 1 minus 2, and then x plus 4 squared. Okay? Whatever is in the parentheses replaces the x. All right, so we have to square x plus 4. Okay? So again, over here, let me leave the rest. So we got 1 minus 2, and now I'm going to go ahead and do x plus 4 squared. Well, x plus 4 squared looks like that. And if you remember how to multiply that out, we use something, most of you guys learned how to do this as FOIL, first, outer, inner, last. We have to multiply everything in the first parentheses times everything in the second parentheses. So you have to multiply the x times this x and this 4, and then you got to multiply the 4 times this x and that 4. So that's hopefully you remember, most of you guys learned it as FOIL. First, outer, inner, last, right? Okay, so I'm going to do the work over here and then we'll put it over here. So first would be x times x, the first two things in each parentheses, that's x squared. Outer would be x times 4, the outer terms. So x times 4 is 4x. I stands for inner, which are the inside terms, these guys. So 4 times x again is 4x. And then L stands for the last two terms. So that would be the 4 and the 4. 4 times 4 is 16. And you can add these together. Those are like terms. 4x plus 4x would be 8x. So we end up with x squared plus 8x plus 16. Okay, that's just x plus 4 squared. So I'm going to write that over here. Okay, that's what I got when I squared it. So x plus 4 squared gave me this. So that's what I put in here. Now we're going to multiply everything by this minus 2. And be careful because that's minus, okay? So I always tell you guys when you're multiplying, treat the sign in the front as the sign of the number so that you don't lose your signs. So you're not going to do 2 times each of these. You're going to do negative 2 times each of these. Okay, so you're going to do negative 2 times x squared, negative 2 times 8x, negative 2 times 16. Okay, so negative 2 times x squared is negative 2x squared. Negative 2 times 8x, that's negative 16x. And negative 2 times 16 is a negative 32. All right. Now you're just looking for like terms to add together. So I don't have any other x squared terms. I don't have any other x terms, but I do have 1 minus 32 that I can add together. So I'm going to put these in descending order. So I'm going to put the negative 2x squared first, the negative 16x, and then 1 minus 32, that's minus 31. Okay, so that would be your answer, the output. Okay, all right. So hopefully you're getting the hang of this. You're just substituting in whatever it is that you see, whatever you're given in for x. All right, and then part D, find f of x plus h. So that's very similar to what we just did here, right? Instead of substituting in x plus 4 for the x, I'm going to substitute in x plus h. Okay, so it's going to look very similar to the one we just did. So that means take your expression 1 minus 2x squared, and in place of x, you're going to put x plus h. Okay, so looks like that. All right. Okay, so It's going to be very similar to what we just did, except we don't have any numbers. We just have the x plus the h in there. All right, so I'm going to come over to the side and again do the x plus h squared. Okay, so x plus h squared means that's another FOIL problem. So we're going to leave the 1 minus 2, and let's go ahead and multiply this out. So first, outer, inner, last. So first is x times x squared. Outer, x times h, that's just xh. Inside, the inner, you have h times x. So some of you might write hx, and that it's a little confusing. But remember, when you multiply, the order doesn't matter, right? You can say 4 times 3 or 3 times 4. So I can say x times h or h times x. It doesn't matter. But just so that you see that they are the same, I'm going to write them the same way. Okay, so even the inside, hx, that's the same thing. Okay, you can only do that, right? Multiplication allows you to multiply in any order. Okay, 2 numbers like that. All right, and then last, h times h, that's h squared. Okay, so again, you can add these. Okay, so think about that. When you're adding, it's how many altogether. So if you have one xh here and you have another xh here, how many xh's do you have altogether? Okay, that would give you 2 of those. Because a lot of you guys would tell me that's x squared, h squared. Okay, you don't change the variables. How many xh's do you have? That's why you're looking for those same things. So you have 1 here and 1 here, so that's just 2 of those. You don't change the variables. And then you have the h squared at the end, right? All right, so x plus h squared is this. So that's what I'm going to write here. All right. And now, just like we did above, we're going to multiply everything in this parentheses by -2. So leave the 1 right where it is. And we're going to do -2 times x squared, which is -2x squared. We're going to do -2 times 2xh, which is -4xh. And then we're going to do -2 times h squared, which is -2h squared. It's kind of running in there. Okay. All right. Now, on this one, I have absolutely nothing to add together. I don't have any other x squares to add to this one. I don't have another xh term. I don't have another h squared term, and that's just the 1. So I don't have anything else to do but to put a box around it because that is the answer. Okay? All right. So, you know, hopefully you guys remember some of this stuff, and this is good practice. But the more you practice and work with variables and remember your addition rules, your multiplication rules, lots of things that you're going to need. So make sure that all this is making sense and coming back to you. Okay? All right, number 3. This looks a little different. Hopefully you remember what these kinds of functions are called. Okay, when you're given a function and you're given more than one expression, then these are called piecewise functions. Okay, we're going to use different functions based on what x is. So we're piecing different functions together. So that's where it gets its name, piecewise. Okay, these are piecewise functions. So we're going to use 2x minus 3 if the x given to me is less than or equal to 5. And I'm going to use -4x squared minus 3 if the x given to me is greater than 6. Okay? If it's anything other than that, then I can't do the work. Okay? So you got to pay attention to the numbers given to you. All right, so first off, find f of 5. And we're still replacing any x with this number, but now we got to choose which expression I'm going to be using. Okay? So this one is 5. Well, does 5 fall into this group or this group? Well, 5 is definitely less than or equal to 5. It is not greater than 6, right? So I'm going to use this function here. So f of 5 is 2. I'm going to write the expression. I'm going to use this expression, right? Because that's the one that I need. So I'm going to put 5 in here. So that's 2 times 5 minus 3. 2 times 5 is 10. 10 minus 3 is 7. So there's my answer for that one. So it all depends on what value you're given on which expression you're going to use. All right, f of negative 3. Okay, is negative 3 less than or equal to 5, or is it greater than 6? Well, negative 3 is less than or equal to 5, so I'm still using 2x minus 3. So to find f of negative 3, I'm still going to use that expression, okay, because that falls into that category. All right, so I'm going to plug in negative 3 for x, like we've been doing, and work that out. So 2 times negative 3 is negative 6. Negative 6 minus 3 is negative 9. So there's the answer for that. All right, f of 7. 7. Is 7 less than or equal to 5, or is it greater than 6? Well, 7 is greater than 6, so now I'm going to use this expression. So I'm going to write that down here. For f of 7, I'm going to be using negative 4x squared minus 3. Okay? So in place of this x, I'm going to replace it with 7. So negative 4 times 7 squared minus 3. All right, so again, you do powers before you multiply. So we're going to do 7 squared first. So leave that negative 4 there. 7 squared is 49 minus 3. Okay. Then you're going to do 49 times negative 4. So 49 times negative 4 is negative 196 minus 3. And negative 196 minus 3 is negative 199. Okay. So just take your time, do your steps so that you don't make any careless mistakes with your arithmetic. Okay. All right, and now look at D, f of 6. Okay. F of 6 is not a number less than or equal to 5, and f of 6 is not a number greater than 6. 6 is equal to 6, and nowhere in here do I have a spot to put or an equation to use when x equals 6. Okay, these numbers are 5 and less. These are bigger than 6. So 6 is not in here. So I cannot work this out because it doesn't fall in any of the x value ranges that were given to me. So on this one, we're going to write no solution. Okay. Sometimes it'll give you something like the empty set or something like that, but you can't work this out because it's not part of the domain, the x's that were given to you. Okay, remember, these are the domain values, the x's. And 6 was not one of those domain values. Okay? All right, so that's a lot with working with functions. So now let's look at the graphs. Okay? So if you're given a graph, the biggest thing right now is, can you tell me whether or not that graph represents a function or not? So remember what a function was. All the x's have to be different. They have to be paired with one unique y. Okay? So it's kind of hard to do that on a graph unless you remember that a vertical line test will help you determine that. So remember what the vertical line test said. If you can draw a vertical line through a graph and it crosses the graph in more than one place, then it is not a function. As long as the vertical line only crosses the graph once, then it's a function. And you have to be able to do it anywhere on the graph. Okay? So if you look at number 4, part A, if I draw a vertical line anywhere on this graph, it's going to cross the graph only once. No matter where I pick, it's only going to cross the graph once, right? Any vertical line. So as long as the vertical line only crosses the graph once at all places, then yes, it is a function. Okay? So this is a function. If you look at part B, if you draw any vertical line through this graph, it's going to touch that graph in 2 places. Anywhere you do that, you're going to get 2. And you only have to find 1. Okay? As long as you find just one vertical line that crosses in 2 places, it is not a function. So this is not a function. Okay? All right. So the vertical line test is really nice because if we don't have an equation listed out where we can actually see what we're working with, that's a great way to be able to tell if it's a function or not. All right, so looking at part C, if you draw a vertical line through any kind of circle, it will cross the circle twice, right? So if it crosses in more than one place, it is not a function. Okay. Part D, if you draw a vertical line anywhere on this graph, it's only going to touch once. No matter where you draw a vertical line, it's only going to touch once. So this is a function. Okay. So that one worked and the first one worked, but B and C did not. Okay. All right, I'm going to stop here just for the recording, and I'm going to pick up again in part 2, and we'll start with number 5. Okay. So I'll see you back here in a few minutes. Look for your part 2 video.